Hi, I'm Gando, and for my senior project, I did the RC Baja car, the driving and steering part, and then for the other part of the car, my partner Chesna did the suspension and chassis. So the point of the RC Baja car was to be able to compete in the ASME Baja competition, which contains 3 different courses. The first one is a sprint. The car travels between 2 lines in a matter of time, and then the second one is the slalom, which the car needs to pilot, goes through pylons and navigate and weave through those. And then the third one is the Baja challenge course, which the car has to go through different terrains and different challenge objects like a ramp or stairs. So from those 3 objectives for the car, which played a role in my analysis, for looking at speed for the sprint, and then looking at the turn radius for steering, and the other torque for ramp. So the first analysis that I did for the project was to look at what the gear ratios needed to be able to get a nice high speed of 30 miles per hour in calculations. And then for the second analysis that I did was to be able to find out the torque it needed to be able to climb up the ramp, which a slope of for 2 feet, a height of 2 feet, and then moving on to what the gear ratios needed to look like overall over here, different axle types, and seeing if it would be able to withstand the stress and torque through the gearbox. And then moving on to the steering part, because for this slalom I need to be able to pivot within a reasonable amount of degrees. So calculating the overall width and the tires and seeing what the lengths it needed to be. So moving on from the design phase, we move to the construction phase of the project. So I don't know a lot about RC cars. This is the first time I ever built one. So I did need a lot of prototyping during the design and construction part of the phase. And I really don't know anything about RC car parts. So what I do know is Lego parts. So a lot of the things I've done for this project was do a lot of prototyping and mock-ups with Legos, because that's the resource I had and know. So we're going to watch some of these videos that have mock-ups that we did. So I can relay back to my analysis and double check that the amount of torque and the gear ratios work together, and double check my calculations. Just another, this one's just another simple looking at the motor and seeing what gears work and seeing if it can withstand the amount of torque. And this one looks more near to what the overall final design would look like, the amount of speed that the motor was giving out. And this is a picture of what overall would the final design look like. And then over here is a mock-up of what the steering would look like, to 3D print most of our parts for the car, which was great because it was free able to design, and we were lucky to have Mr. Kern, Chesna's father, be able to access their school printer and basically print when we needed parts and all of that, and was able to redesign if need be, which was great. And then from that 3D printed parts, we were able to make parts like their differential holder for the gears, and then these following pictures were the gearbox setup. So this was one side of the gearbox, which had the high speed, and then this other one was the high torque part of the gearbox, and then together we made one gearbox, and then which connects to the car. And then right here we have the overall design of the steering. So now we move on from building and constructing to the testing part of the project. So from the beginning we set those requirements for the car for the speed test. This was the test that we were done in the Fluke Lab in Hogue Hall. It passed this time, but then sometimes during testing the floor is kind of a little slippery, so you get some tests like this. And you can see that it spined out because the floor sometimes didn't grip onto the wheels correctly. So we just took all the successful tests and mitigated all the failed tests for the data. We also tested outside, so look at that too. So this is one of the successful tests. It passed this line to that line over here, which is a little out of frame. And overall, what was recorded for data It did pass the minimum requirement for 10 miles per hour, which still means it's successful on the being able to have a decent speed for the competition later. This was looking at ramp tests for the challenge course for Baja. So this is what it looked like for the 10 degrees ramp. So it's passed, and then we moved on to doing a 20-degree ramp. Was also passed, so it was able to go up the ramp. And this was mainly focused for helping the car to steer later, which was good for the slalom test. So that's a pass. So some other tests that were out of my scope for the project, which look more on the chassis and suspensions, but does affect the whole car, was the drop test. The radius test, which that was successful. It was able to withstand within the 3-foot radius. And then lastly, the other test we did was the impact test, which looked at the front of the car, the bumper. Sadly, it did not pass, so it did affect another change and fix on the car. During the testing, there was a lot of things that broke and changes that we needed to make, so just being able to rapidly change it with 3D printing and other parts. Also, sometimes the Lego parts fail, and for this one, the hole was widened so that the plastic didn't rub on plastic and it didn't melt each other, especially when this motor is running at high speeds. Also, there was some torque done on the teeth. You can kind of see they're kind of warped, so different materials were used or different ways to power the motor was used. And then, so originally for this picture, the motor used a plastic 3D part, but it kept failing during the beginning stages of testing, so we moved it. I took an old gear and basically stripped it to use as a hub, and was able to attach the gear so that it wouldn't break or strip during the high torque of the motor. So next I'm going to talk about our budget. Overall, the goal was to be for the whole car under $400, and how that was divided between the two of us, being Chesna, was $200 each. Thankfully, for some major components, we were able to use secondhand from the MET department. Most of the cost comes from the main drive components, so bearings and axles and collars, metal collars that were used, the special screws that were for the drivetrain. Thing was very cheap because we just bought the filament, and then from that we were able to print as many parts as we needed. Then moving on to the gearbox of the drivetrain. Thankfully, I already own most of the Lego parts that we use on our chassis. Barely any costs on the steering part, just more on the drivetrain box. And then from outsorting, main components were from 3D printing, which was from Mr. Kern and the university, and then other parts were purchased from Amazon. And this is about overall budget breakdown. So a lot of it, the box was $110, and then some more 3D parts for the gears and mounts. Then overall, the cost was $198, which was for my budget $200. So that it was under budget, so we're going on that. So now moving on to the schedule part of. the project. During the fall quarter was mainly the design part, and doing other things to start the project. Some of the things weren't able to design within the first part. Luckily, we did have a 6-week winter break to catch up and change things and redesign things in SolidWorks and stuff, and analysis and checking things. And then for winter quarter, we barely made the finished deadline of the project running, but thankfully we did make that deadline, and the car was running. But after that, there were some problems after the few initial tests, so then we had to go kind of back to the drawing board and do some redesigns. But thankfully, we were able to get it back up and running with a gearbox redesign, and the car was working fine after the last parts of testing. And we were able to turn in testing on time. Unfortunately, with the timeline that we were not able to fully compete in the ASME competition, which was kind of sad, but it happens with projects like this, especially when you're very new to building an RC car. So last but not least, this is my contact. My resume is in the bottom of my website. My website is jazon.wixwebsite.com/MET Senior Project if you want to access my website for anything else. Thank you for watching.